Alright, these are the notes for Algebra 2. We're dealing with factoring trinomials, and this is day 2 of factoring trinomials. Now the difference between what we did in day 1 and what we're going to do in day 2 is actually very small. Basically, we're going to look at a few examples of times when you can't factor a trinomial, and we're also going to look at factoring out a greatest common factor before you do the box method to factor. So I want to start by looking at this example 1, and what I want to do is anytime I'm factoring a trinomial or a binomial or anything, the first thing I want to do is see if I can find a greatest common factor. I want to see if each term shares a greatest common factor. If it does, if they all share a common factor, I'm going to factor that out first. That will make the factoring that I have to do later easier, and it will be more accurate. So I look at 3x to the third, 15x squared, and 27x. Now all three of these terms, as we saw when we did factoring with greatest common factors, all three of these terms share 3x. So 3x is going to be part of my answer. But what I do now is, just like I did when we did GCFs, I put the 3x out front of some parentheses, and inside the parentheses I will put the results of dividing each term by 3x. So 3x to the third divided by 3x is x squared. Negative 15x squared divided by 3x is negative 5x. 27x divided by 3x is 9. So factoring out a greatest common factor leaves me with 3x times x squared minus 5x plus 9. That's what we did when we worked with greatest common factors. But we're going to add another dimension to this, and that is we want to see if the resulting trinomial inside these parentheses is factorable as well. We'll be doing two types of factoring in this case. We'll be factoring out the greatest common factor, which we've already done, and we'll be using the box method to factor what's left over inside the parentheses. So let's get our box method together. We draw our box. We put the first term in top left and the last term in bottom right. For the purposes of this, I'm not looking at 3x. I'm just looking at what's inside the parentheses. Now I multiply together 9 times x squared. I get 9x squared. Now I would want the factors of 9x squared that add up to negative 5. My factors of 9x squared are 9x and x, and 3x and 3x. There aren't any other factors of 9x squared that I can see. Now, 9x and x will not combine to give me 5x. 3x and 3x will also not combine to give me 5x. What that means is that none of the factors works. If none of the factors works, then the trinomial is not factorable. And that's what we would say. This is not factorable. We could also say it's prime. So we can't factor this trinomial. We're just going to have to leave it the way it is. But we did factor out this greatest common factor, so that has to be part of our answer. 3x times x squared minus 5x plus 9, which is not factorable. And that is our final answer. Moving on to example number 2. Now this one looks a little strange. Again, on the second day we're looking at some that might look a little strange. What we'll see is that they behave very similarly to everything we've done up to now. First thing we want to do, as with any any polynomial that we're going to factor, we want to see if there is a greatest common factor that we can factor out first. So I look at 20x squared, I look at 45, and I say, hey, I can factor out a 5 from both of these. So I'll put a 5 outside parentheses. 20x squared divided by 5 is 4x squared. 45 divided by 5 is 9. So I have 5 times 4x squared minus 9. Now I want to see if I can factor this binomial. And even though it's not a trinomial, I'm willing to bet that I could probably factor this. Now, what we need to keep in mind is that I do have a first term, I do have a last term. First term is 4x squared, last term is negative 9. But you'll notice I don't have a middle term. That means that the middle terms, you remember when we did multiplication, they canceled each other out. So that means they were the same number, but they had opposite signs. So plus 7 and negative 7, plus 3 and negative 3, so on and so forth. So basically, at this point, what I'm looking for when I do my factors are terms that are the same number but opposite signs. I multiply 4x squared times negative 9, and I get negative 36x squared. This is all what we did in the first day of factoring. And I look at the factors of negative 36. Now, as I said, since these two factors are going to have to cancel each other out, that means that the terms that we're looking for, or the terms that we're looking for should be the same number. And if we're looking for the same number, that means that 36 should be a perfect square. It should be one number squared. And in fact, it is. 36 is 6 times 6. That would be how we get the same number. Since it's negative 36, one of them would have to be negative. Now, 6 times negative 6 is negative 36. And 6 plus 6, or negative 6 plus 6 does cancel out. So my terms in my boxes should be 6x and negative 6x. I can always figure that out by looking at the square root of my number here. So the square root of 36 was 6. That means my two factors had to be 6 and 6. That's kind of a handy-dandy little trick. Not necessary. You can still get this the old-fashioned way, but it's a nice little trick to know that can speed up your life a little bit. Now from here, we've got our regular box. So we work this out the regular way. The greatest common factor of my column here would be 2x. The greatest common factor of my row would also be 2x. Now to make 2x become 6x, I'd have to multiply it by 3. 2x times 3 is 6x. 2x times negative 3 would give me negative 6x. And of course, negative 3 times 3 is negative 9. That means that my factors here are 2x plus 3 and 2x minus 3. Now here's where the trick is. I have to leave the 5. Remember that 5 that I factored out at the very beginning? That stays there. It's still part of my answer. So I'm going to have 5 times 2x plus 3 times 2x minus 3. And that is my complete answer. It has to contain the 5 that was the greatest common factor, and then the factors that I got from using the box method. Let's look at another example here. I have 12a squared minus 4a minus 8. And again, since I'm factoring, the first thing I want to do is see if there's a greatest common factor. So I look at 12a squared, 4a, and 8, and I say, well, I can factor out a 4 from each of those. So I do have a greatest common factor of 4. Now when I factor out a 4, I'm left with 3a squared minus a minus 2. 3a squared minus a minus 2 is what I want to attempt to use the box method on. And as we saw before, if I cannot factor it, I'll leave it the way it is. But if I can factor it, I'll have to do that. So I have 3a squared in the top box, negative 2 in the bottom. Multiply the two together, I get negative 6a squared. And I want the factors of negative 6a squared that add up to negative a, just like we did the first day. And we go, okay, well that's negative 3a and 2a. Negative 3a times 2a makes negative 6a squared. Negative 3a plus 2a is negative a. So those are my terms. And I'll put those in the box. Now I want the greatest common factors, just like before. Of the column, the greatest common factor is a. We can't factor out a 2 or a 3. We just have a. On the side, on this row, the greatest common factor would be 3a, because both of these terms do have 3a in them. To make a become 2a, a times 2 is 2a. 3a times negative 1 is negative 3a. So my factors are a minus 1 and 3a plus 2. And I will put those next to the 4 because that doesn't go away. Instead, it just becomes 4 times a minus 1 times 3a plus 2. And that is my final answer. One last example. This one might throw people off, but it is actually pretty easy. It will require a calculator, but that's okay. I have 81b squared minus 49. Now, this is a binomial, but we can still factor it. First step, we want to see if there are any greatest common factors. So I have 81 and 49. Well, the factors of 81 would be 1 and 81, 3 and 27, 9 and 9. 49, I have 1 and 49, and I have 7 and 7, but that's it. These two numbers don't share a greatest common factor. There is no greatest common factor between these two. So I'm not going to be able to factor anything out. I just have to jump straight to the box. So I'll draw my box. I'll put 81b squared in the first, negative 49 in the last. Now, we saw before when we did example number 2 that since the middle term isn't there, that means that the numbers in these two boxes have to cancel each other out. If the numbers in these two boxes have to cancel each other out, that must mean that when I multiply these two together, it's a perfect square. And it will be. In fact, when I multiply these two together, if you use a calculator, which I did, I couldn't do this in my head, I got the number 3,969 b squared. 3,969 b squared. Now, in fact, negative 3,969 b squared. Now, that is a huge number. But we do have a clue in that since the two middle terms have to cancel each other out, 3,969 must be a perfect square. So rather than try and find all of the factors for it, I'm just going to take the square root of it. And if I take the square root of 3,969, I get 63. So one of my factors would be positive 63b. The other factor would be negative 63b. It has to be that way. That's the only way these two will cancel each other out. I don't even need to think about the other numbers. Let's just put it out of my head. So I'm going to use 63b and negative 63b. So what you're seeing is that it is possible to do this method with really, really big numbers, because there are usually clues that you can work with, and there are usually ways to simplify it. Now, from here, process exactly the same as it has always been. I want the greatest common factor of 81b squared and negative 63b. And that happens to be 9b. Because 81 divided by 9 is 9. 63 divided by 9 is 7. So 9b is the greatest common factor. Since this is also 81b squared and this is 63b, it's positive this time, it must also be the factor over here. Now I make 9b become 63b by multiplying it by 7. I make 9b become negative 63b by multiplying it by negative 7. So my factors then are 9b plus 7 and 9b minus 7. I didn't have a greatest common factor at first, so that is all I'm left with. Now, there are 2 checkpoint questions that I want you to work on. Try and answer those questions and bring them to class tomorrow. Keep in mind that we have already done factoring trinomials, so you do have a leg up in answering both of these problems. Just make sure to factor out a greatest common factor first if you can.